Hey guys, welcome to another edition of Physical Science Online. I hope you're hanging in there. I know I am. Having a great time, realistically. Today we're going to be talking about acceleration. So I hope you're ready. Let's go ahead and let's just dive in it. So, first thing we need to know about acceleration is we need to know the formula. And the formula here is A is delta V. Delta means change in velocity divided by time. That's our formula that we're going to be working with. So we'll probably be given two different velocities, a start and a finish, and then we'll be given a time, and we're going to have to figure out what acceleration is. So actually, I like to think that this is a little bit easier than the velocity problems, but let's get to it. Okay, acceleration. A is delta V divided by T. Notice how I'm always writing down my equation beforehand, like a professional. You know what I'm saying? Always writing that ahead of time. Now I got to figure out what my change in velocity here is. Now, if you guys remember from when we talked about this, change in velocity is always what you end up with, your V final, minus your initial velocity. So Vf minus Vi is delta V. That's what we need to know. So in this case, we start with an initial velocity of 0. So our change in velocity is also just our final velocity, 12 meters per second. So instead of writing down delta V here on my new equation, I'm going to write down 12 because that is my change in speed. Then the other part is time. Time is 3.4 seconds. Great, let's solve it. 12 divided by 3.4, that should spit us out a number that's somewhere less than 4. So if you guys already done this, it's going to be something less than 4 but greater than 3. I get 3.5 when I do this. I'm just going to put one decimal point here. 3.5. I guess it's technically 3.53, but we'll just call it 3.5 meters per second squared. That's the unit right there, meters per second squared. Remember, velocity is meters per second. And then you're dividing it again by time, which is seconds. That's where you get the meters per second, or meters per second squared. That's where that comes from. Sound good? Great. Okay, now, another thing you're going to need to know is the 3 ways you can accelerate. Remember, acceleration is change in velocity divided by time. So, do you remember this? Test yourself out. What are the 3 ways to accelerate? Pause the video. Try these out. Okay, 3 ways to accelerate. Here they are. You got to change your speed. There's 2 ways you can do that. You can, number 1, you can speed up. That's absolutely one way to increase your velocity. That increase in velocity over time is acceleration. So speed up. Number 2 is you can slow down. Absolutely. If you're slowing down, again, you're changing your velocity over a period of time. That works. The third one's a little bit tricky. We did talk about this. It is change direction. That's the third way that you can change your acceleration. Hopefully you have this down somewhere in notes. If not, pause it, write this down. Sound good? Last thing we got to talk about here is some distance versus time graphs and some velocity versus time graphs, looking at how acceleration looks. So here is a distance versus time graph. You might have seen this before. When you're not moving, here's what it looks like. It's just a flat line, right? So this, in this case, my distance or my displacement is not changing at all. Let's look at a slightly different one where we're accelerating positive, or sorry, this is a constant velocity. There's no acceleration here, actually. And then here is a constant negative velocity. There we are, sloping the other way. Cool. Hopefully this makes sense as we explained in the other video. If not, take a look at that other video. Kind of talked about it. Positive slopes, positive velocities. Negative slopes mean negative velocities because slope, remember, is velocity. That's the thing. And then the absolute value of that slope, remember, that's speed. But we're talking about velocity right now. Okay, so here's what not moving looks like on a velocity versus time graph. What I want you guys to notice is that since my speed is not, or my distance is not changing over time, I have no velocity, so that velocity would just be 0 the entire time. Here is a constant positive velocity. Again, since my velocity is not changing over time, it's just a straight line. But here it's going to be some positive value. If I had a negative velocity, I'd be sloping kind of downwards here. So far, so good? Hopefully so. And then just so you're aware, in class, remember, we did talk about positive accelerations and negative accelerations. When it comes to positive accelerations, they kind of look like a U shape. Negative accelerations look like an N shape. So maybe that helps. You know, negative acceleration looks like an N. Positive accelerations looks like a U. Another way to think about it is positive accelerations are always counterclockwise, and negative accelerations are always clockwise. Those are two true facts, so either ways you can work with that. But the more important thing I wanted to say here is that your negative acceleration is going to have, on a velocity versus time graph, is going to have a negative slope. So just like how we said in a distance versus time graph, your slope is velocity, in a velocity versus time graph, your slope is acceleration, because there's a change in velocity over time. And then a positive acceleration here will have a positive slope. So expect to see pictures like this on the test, where we give you slopes of a velocity versus time graph, and we kind of ask you, okay, is this a constant velocity? Is it accelerating? Is it accelerating positively? Is it accelerating negatively? Those are the type of questions we can ask. And there's a couple questions on the review, little Schoology type quiz. It's a review, it's not worth quiz points. But go ahead and do those to test yourself out, see how comfortable you are, and to prepare yourself for the test. I hope you guys do feel more comfortable. Thank you so much for watching, and have a great rest of your day.